Welcome to tonight's video on the law of sines. Today we're going to talk about how you would solve a triangle that is not a right triangle. And a non-right triangle is called an oblique triangle. And the two types of triangles that are not right by the angles are acute or obtuse. So in this case, it's either going to be an acute triangle or an obtuse triangle. And remember, the capital letters stand for the angles, and the lowercase letters equal the sides opposite the angles. So for example, A, capital B, capital C, and then side A would go opposite angle A, or sorry, side A would go opposite angle A, side B opposite angle B, side C opposite angle C. It doesn't matter where you put A, B, and C in this because there's no right angle. In this obtuse triangle, same thing. You just put the angles and then the sides. So the reason why the law of sines works is because if you draw the height of this triangle here, then in either one of these, you could have sine of A equals h over b, and you could also have sine of b equals h over a. And so if you solve for h, you get h equals b sine A. You get h equals a sine b. Set them equal to each other because they're both equal to h. And then if you notice, if you divide by sine b and sine A on both sides, notice those cancel, and you're left with b over sine b equals a over sine A. And you could do the same thing if you drew the height for side C. So that's how the law of sines comes about and how you are able to solve a non-right triangle using trig ratios of sine. All right, so let's get into the use of the law of sines. There are two situations where you guaranteed easy peasy law of sines, and that is when you have side angle angle or angle side angle. So here's a side angle angle triangle. So the first thing we're going to do is draw the triangle. So we'll put angle A, B, C, and then so angle A is 46. Then here it's 63, and then 56. So we're missing A, side B, and angle B. So those are the three things that we're missing: angle B, side B, angle A. Second, it would be easiest to find angle B. So you'd find the missing angle by taking 180 minus the sum of the two angles. So in this case, angle B is equal to 180 minus 63 plus 46. So it's 180 minus 109, which is 71 degrees. So that is angle B. Then, to find the missing sides, we're going to use the law of sines. So, we're going to take 56 over sine 63 and set that equal to, and if we want to find A, we'll go A over sine 46. And then same thing, but then if we want to find B, it would be B over sine 71. You're going to have to get out your calculator because here you cross multiply. So it's A sine 63 equals 56 sine 46. And then you divide by sine 63. And you get A equals 45.2. Here you do the same thing. So B is going to equal 56 times sine 71. But then you have to divide by sine 63. And you get B is equal to 59.4. So those are your missing sides. All right, the next one is an angle side angle triangle. So when you draw, you have A is 40, B is 76, and C is 33.5. Notice it's angle side angle because the side is between the two angles. But the process is still the same. We drew the triangle, then we could find angle B by going 180 minus 40 plus 33.5. So 180 minus 73.5 gives you B is equal to 106.5 for the angle. Then to find the sides, we're going to use the law of sines. So we go 76 over sine 106.5 is equal to, if I wanted to find A, so A over sine 40. And if I want to find B, it would be 76 over sine 106.5 is equal to B over sine 33.5. Or sorry, if I wanted to find C. 33.5. So then when you solve, A is equal to 76 sine 40 divided by sine 106.5. So when you multiply in your calculator, you get that A is equal to 50.9. And then here, C is equal to 76 sine 33.5 divided by sine 106.5. And you get C is equal to 43.7. So there are your three missing parts that you needed to find for this triangle. There is a third case, which is what's called the ambiguous case. If you're given two sides and an angle opposite one of the sides, it is not guaranteed to give you a triangle, or it could give you one or two triangles depend upon. So it says here, consider a triangle which side B, and angle A are given. The information may result in the following. So if you look, let's say you have angle A, B, C. You have the height here of the triangle. And remember, the height of the triangle is going to be B sine A. Because remember, it's going to be, here's B, so it's going to be the sine of A is H over B, and then you can make it B sine A. Here's A, here's C. So there's one triangle if side A is greater than the height, right? If side A is longer than the height, then there's guaranteed to be one triangle. And if side A is greater than or equal to side B. So if A is greater than the height, and if A is greater than or equal to B, then there's at least one triangle. It's a right triangle like this if side A is equal to the height, right? If this is A, it's the height, then it's a right triangle. There is no triangle if side A is less than the height. Because if side A is less than the height, then that means it does not connect to the B. And here's where it gets tricky. There's two triangles Yeah, let's try that again. Here's the height of the triangle. And here's the second B. All right, there's two triangles. If the height is less than side A, but side A is less than B, there's two triangles. So there would be this obtuse triangle here, and there would be the acute triangle there. And what you notice is because these two sides are the same, and this is angle B1, that this is also angle B1, but this would be B2. So angle B1 and B2, the first B triangle and the second one, are going to be supplementary if there are two triangles, that the two angle B's would be supplementary, the two angles opposite the angle you know. So there would be two triangles. So basically what you would have to do is make a list of the parts in the two triangles. There would be an angle A, there would be one angle B, there would be an angle C. The angle A would be the same in the second triangle, but the angle B would be different along with the C. Now for the sides, side A and side B would be the same in both triangles. The only thing that would change is side C for that triangle. So let's look at some examples. So let's look at one triangle that has one solution, and here's how we're going to tell. So the first thing we're going to do is draw the triangle, like we always do. So we're going to put angle A is 43, side A is 81, side B is 62, and then we have side C there. Okay, so the first thing we're going to do is find the angle opposite the side given. So you know how we know angle A and side A, and we know side B. Now we're going to find angle B. So we're going to use the law of sines. So we're going to go sine 43, 81 over sine 43 equals 62 over sine B. Then you're going to cross multiply. So you get 81 sine B equals 62 sine 43. And then divide by 81. So you get sine B equals 0.522. So then B is going to be sine inverse 0.522 on your calculator. So B would be approximately 31 degrees. So now, to determine if there is two triangles, the second B angle is supplementary to the first one. So it'd be supplementary to 31 degrees. So 180 minus 31 would give me 149. Now, what you're going to do is you're going to say, okay, if there were two triangles, then it would be in the same triangle with 43. So then 43 plus 149 has to be less than 180 in order for that to be a triangle. Well, 43 plus 149 is 192. That is greater than 180. So there's only one triangle. So that's how you determine if there's one triangle. All right, so it's too big. So there's only one triangle. Now, the fact that we know there's one triangle, this is 31. We can then find the missing sides. Actually, sorry, we're going to find the angle. So angle C would equal 180 minus 43 plus 31. 180 minus 74 is going to give me 106. And then to find the side, the missing side of C, C over sine 106 is equal to 81 over sine 43. And then you divide. So you get C equals 81 sine 106 divided by sine 43. So you'll get it's approximately 114.2. That would be C. So there's the three parts that we're missing in the one triangle. Now, for the next one, if there's no solution, so same thing, we're going to draw the triangle. We'll put A where we normally put it. No degree. Okay, so finding B. So we go 71 over sine B equals 51 over sine 75. So you get 51 times sine B equals 71 times sine 75. Divide by 51. And when you do that, you get sine B equals 1.345. When you do B equals sine inverse of that, notice it gives you no solution because that means you cannot have a sine bigger than 1. So if it gives you no solution or an error, that means there is no triangle that is formed.